everyone. We are here today to present our project for the Automata Theory and Computation course. So our topic is web-based visualizer for structural representation of C programs. I am Agni and my teammates are Anu, Bhumika and Manushri. In this project, we have built a tool that bridges the gap between high-level programming and the complex representation used by modern compilers. So moving on to the introduction. To a programmer, a C program might look like a simple text, but however, for a computer to execute that code, it must process in a highly structured way. So before execution, we have used the source code to analyze and also convert it into a different representation that describes its syntax, control flow and data relationships between those analysis. These representations are not just for traditional compilers but also like AI assistants like ChatGPT, Gemini and also other AI tools. We have used the similar graph-based techniques to understand and debug our code. So moving on to the problem statement, the primary challenge of this assignment is to design an automated interactive web-based framework that is capable of performing static program analysis. There are traditional ways where the software documentation and academic grading evaluates code very simply as a flat sequence of characters, but this primitive perspective might fail to expose how a program actually runs. So the software platform must accept a standard high-level C code input string, immediately compile its lexical structure and dynamically map out its exact operations. So what we have done here is we have used, instead of forcing users to install complex local compilers, we used a backend database or graph software. We designed a lightweight client-side browser using web technologies through HTML5, CSS and JavaScript, also using the Mermaid JavaScript. Next will be continued by Anu. Thank you.
Now I will explain tokens and lexical analysis. Lexical analysis is the first stage of the compilation process. In this stage, the compiler reads the source code and breaks it into small meaningful units called tokens. Tokens are the basic building blocks of a program. There are different types of tokens: keywords, identifiers, operators and constants. Keywords such as int, if, else and return. These are the reserved words with predefined meanings. Identifiers such as A, B and C. These are the names given to variables. Operators such as equals and lesser than or greater than, which are used to perform operations. Constants such as numbers 5 and 10, which represents fixed value. For example, in the statement, if of A is less than B, the words if A less than and B are identified as different tokens. Lexical analysis helps the compiler understand the program correctly and prepares it for the next stage of the compilation. Abstract syntax tree. An abstract syntax tree is a tree-like representation of the structure of a program. It shows how different parts of the program are related to each other. In our program, the AST contains the main function, the variable declarations, the condition, assignment statements, the printf statement, and finally return. The AST focuses on the logical structure of the program rather than the exact syntax. Some advantages of the AST are: it simplifies the program structure, it helps in syntax analysis, it is widely used in compiler design and code optimization. Thus, the abstract syntax tree makes it easier for the compiler to analyze the process and program efficiently. Next will be continued by Manushri.
A CST shows the order in which program statements are executed. It helps us understand how control moves from one statement to another during program execution. In our program, first the variables A, B and C are initialized. Then the condition A greater than B is checked. If the condition is true, the program executes C is equals to A plus B. If the condition is false, the program executes C is equals to A minus B. After either the path is completed, both branches merge and move to the print statement, which display the value of C. Finally, the program executes return 0. Importance: CFG is useful for program analysis, debugging, software testing and compiler optimization because it clearly shows all possible execution paths. Next, moving to the next slide, data flow graph DFG. This explains the data flow graph or DFG, unlike CFG, which focuses on the order of execution. DFG focuses on how data moves through the program. In our program, the values 5 and 10 are assigned to variables A and B. These operations. Depending on the conditions, either A plus B or A minus B is calculated. The result is stored in variable C. Finally, C is passed to the print function and displayed as output. And next part will be continued by Bhumika.
So now I'll explain the output generated by our system. So here the code contains the HTML, CSS and JavaScript. So after entering the C source code, when we click on the load sample, the code will automatically generated here, and the tokens, abstract and control flow graph, data flow graph and code property graph here, these are not visible. When we click on the analysis code, what the code is included means here the tokens are included. Here, the first step output is token analysis. So in this stage, the source code is broken down into individual tokens such as the keywords, identifiers, operators, constants, and the symbols. So these helps in understanding the fundamental concept of the program and serves the first step in the program analysis. And the next step is abstract syntax tree. So here the AST represents the hierarchical structure of the source code in the tree format. So each node is represent a programming constant and such as a variables, expressions, operators, and the statements. So these represents the helps users to understand the logical organizations of the program. And the next is a control flow graph. So here the system will generate the CFG. It illustrates the flow of execution within the program and shows how the control moves from one statement to another statement. So it is useful for data dependency and how the important like information is processed throughout the program. And the finally code data flow graph and a code property graph. So here it generates the output and displays through the web-based interface, allowing users to visualize and understand the different aspects of the program in an interactive manner. When it comes to next is conclusion. So here our project successfully analyzes and visualizes the structural representation of a C program. So using a variable programs analysis and techniques. So these represents helps us to understanding the program structure, execution flow and the data dependency more clearly. So here it also highlights the technologies used by the modern AI coding and to analyze and how to understand the source code. So overall the project serves as an efficient educational tool for learning, programming, analysis and code visualization. Thank you.